Development history. Before Dimona, 1949 to 1956. Israel's first Prime Minister David Ben-Gurion was nearly obsessed with obtaining nuclear weapons to prevent the Holocaust from reoccurring. He stated, "What Einstein, Oppenheimer, and Teller, the three of them are Jews, made for the United States, could also be done by scientists in Israel for their own people." Ben-Gurion decided to recruit Jewish scientists from abroad even before the end of the 1948 Arab-Israeli War that established Israel's independence. He and others, such as head of the Weizmann Institute of Science and Defense Ministry scientist Ernst David Bergman, believed and hoped that Jewish scientists such as Oppenheimer and Teller would help Israel. In 1949, a unit of the Israel Defense Forces Science Corps, known by the Hebrew acronym Himed Gimel, began a 2-year geological survey of the Negev. While a preliminary study was initially prompted by rumors of petroleum fields, one objective of the longer 2-year survey was to find sources of uranium. Some small recoverable amounts were found in phosphate deposits. That year, Himed Gimel funded 6 Israeli physics graduate students to study overseas, including one to go to the University of Chicago and study under Enrico Fermi, who had overseen the world's first artificial and self-sustaining nuclear chain reaction. In early 1952, Himed Gimel was moved from the IDF to the Ministry of Defense and was reorganized as the Division of Research and Infrastructure, EMET. That June, Bergman was appointed by Ben-Gurion to be the first chairman of the Israel Atomic Energy Commission, IAEC. Himed Gimel was renamed Machon 4 during the transfer and was used by Bergman as the chief laboratory of the IAEC. By 1953, Machon 4, working with the Department of Isotope Research at the Weizmann Institute, developed the capability to extract uranium from the phosphate in the Negev and a new technique to produce indigenous heavy water. The techniques were 2 years more advanced than American efforts. Bergman, who was interested in increasing nuclear cooperation with the French, sold both patents to the Commissariat à l'Énergie Atomique, CA, for 60 million francs. Although they were never commercialized, it was a consequential step for future French-Israeli cooperation. In addition, Israeli scientists probably helped construct the G1 plutonium production reactor and UP1 reprocessing plant at Marcoule. France and Israel had close relations in many areas. France was principal arms supplier for the new Jewish state, and as instability spread through French colonies in North Africa, Israel provided valuable intelligence obtained from contacts with Sephardi Jews in those countries. At the same time, Israeli scientists were also observing France's own nuclear program, and were the only foreign scientists allowed to roam at will at the nuclear facility at Marcoule. In addition to the relationships between Israeli and French Jewish and non-Jewish researchers, the French believed that cooperation with Israel could give them access to international Jewish nuclear scientists. After U.S. President Dwight Eisenhower announced the Atoms for Peace initiative, Israel became the second country to sign on following Turkey and sign a peaceful nuclear cooperation agreement with the United States on July 12, 1955. This culminated in a public signing ceremony on March 20, 1957, to construct a small swimming pool research reactor in Nakhal Sarek, which would be used to shroud the construction of a much larger facility with the French at Dimona. In 1986, Francis Perrin, French High Commissioner for Atomic Energy from 1951 to 1970, stated publicly that in 1949 Israeli scientists were invited to the Sakhalin Nuclear Research Center, this cooperation leading to a joint effort including sharing of knowledge between French and Israeli scientists, especially those with knowledge from the Manhattan Project. According to Lieutenant Colonel Warner D. Farr in a report to the USAF Counterproliferation Center, while France was previously a leader in nuclear research, Israel and France were at a similar level of expertise after the war, and Israeli scientists could make significant contributions to the French effort. Progress in nuclear science and technology in France and Israel remained closely linked throughout the early 50s. Furthermore, according to Farr, there were several Israeli observers at the French nuclear tests, and the Israelis had unrestricted access to French nuclear test explosion data. The exact cost for the construction of the Israeli nuclear program are unknown, though Peres later said that the reactor cost $80 million in 1960, half of which was raised by foreign Jewish donors, including many American Jews. Some of these donors were given a tour of the Dimona complex in 1968. Weapons production, 1966, present. Israel is believed to have begun full-scale production of nuclear weapons following the 1967 Six-Day War, although it had built its first operational nuclear weapon by December 1966. A Central Intelligence Agency (CIA) report from early 1967 stated that Israel had the materials to construct a bomb in 6 to 8 weeks, and some authors suggest that Israel had 2 crude bombs ready for use during the war. According to U.S. journalist Seymour Hersh, everything was ready for production at this time save an official order to do so. Israel crossed the nuclear threshold on the eve of the Six-Day War in May 1967. Prime Minister Levi Eshkol, according to a number of Israeli sources, secretly ordered the Dimona nuclear reactor scientists to assemble two crude nuclear devices. He placed them under the command of Brigadier General Yitzhak Yaakov, the chief of research and development in Israel's defense ministry. One official said the operation was referred to as Spider because the nuclear devices were inelegant contraptions with appendages sticking out. The crude atomic bombs were readied for deployment on trucks that could race to the Egyptian border for detonation in the event Arab forces overwhelmed Israeli defenses. Weapons production. The first public revelation of Israel's nuclear capability as opposed to development program came from NBC News, which reported in January 1969 that Israel decided to embark on a crash course program to produce a nuclear weapon 2 years previously, and that they possessed or would soon be in possession of such a device. This was initially dismissed by Israeli and U.S. officials, as well as in an article in the New York Times. Just 1 year later, on July 18th, the New York Times made public for the first time that the U.S. government believed Israel to possess nuclear weapons or to have the capacity to assemble atomic bombs on short notice. Israel reportedly assembled 13 bombs during the Yom Kippur War as a last defense against total defeat and kept them usable after the war. The first extensive details of the weapons program came in the London Sunday Times on October 5, 1986, which published information provided by Mordecai Vanunu, a technician formerly employed at the Negev Nuclear Research Center near Dimona. For publication of state secrets, Vanunu was kidnapped by the Mossad in Rome, brought back to Israel, and sentenced to 18 years in prison for treason and espionage. Although there had been much speculation prior to Vanunu's revelations that the Dimona site was creating nuclear weapons, Vanunu's information indicated that Israel had also built thermonuclear weapons. Theodore Taylor, a former U.S. weapon designer leading the field in small, efficient nuclear weapons, reviewed the 1986 leaks and photographs of the Israeli nuclear program by Mordecai Vanunu in detail. Taylor concluded that Israel's thermonuclear weapon designs appear to be less complex than those of other nations, and as of 1986, not capable of producing yields in the megaton or higher range. Nevertheless, they may produce at least several times the yield of fission weapons with the same quantity of plutonium or highly enriched uranium. In other words, Israel could boost the yield of its nuclear fission weapons. According to Taylor, the uncertainties involved in the process of boosting required more than theoretical analysis for full confidence in the weapon's performance. Taylor therefore concluded that Israel had unequivocally tested a miniaturized nuclear device. The Institute for Defense Analyses (IDA) concluded after reviewing the evidence given by Vanunu that as of 1987, the Israelis are roughly where the U.S. was in the fission weapon field in about 1955 to 1960, and would require supercomputers or parallel computing clusters to refine their hydrogen bomb designs for improved yields without testing, though noting they were already then developing the computer code base required. Israel was first permitted to import U.S.-built supercomputers beginning in November 1995. According to a 2013 report by the Bulletin of the Atomic Scientists, which cited U.S. Defense Intelligence Agency sources, Israel began the production of nuclear weapons in 1967, when it produced its first 2 nuclear bombs. According to the report's calculations, Israel produced nuclear weapons at an average rate of 2 per year and stopped production in 2004. The report stated that Israel has 80 nuclear warheads and has enough fissile material to produce 190 more. In 2014, former U.S. President Jimmy Carter stated that Israel has, 300 or more, nobody knows exactly how many nuclear weapons.